Winter, a time of beauty, snow, and sometimes a rather painful slip on the ice. For nearly 200 years we thought we knew why ice was slippery. The conventional wisdom, pressure from an object like a ski or a shoe, created a thin layer of lubricating water. But what if everything we thought we knew was wrong? Scientists have just overturned this long-held belief, and the truth is far more fascinating. Imagine the surface of ice at a microscopic level. It's an incredibly orderly crystal structure of water molecules. Each molecule is like a tiny magnet with a positive and negative end, a dipole. They align perfectly, creating a beautifully structured surface. When something comes into contact with this pristine surface, like your shoe, it's not the brute force of pressure or friction that causes the slipperiness. Instead, it's a subtle yet powerful interaction between the dipoles in your shoe sole and those in the ice. As these two sets of dipoles meet, they create frustration. Think of it like a crowded dance floor where everyone wants to move in a different direction. The competing forces prevent the ice from maintaining its perfect ordered state. The result? The ice's crystalline structure at the interface breaks down, becoming disordered, amorphous, and ultimately it turns into a thin, liquid film. This new understanding fundamentally changes how we view cold weather physics. It means that the slipperiness of ice isn't about how hard you press, but about these invisible atomic-level interactions. But the discoveries don't stop there. Another long-standing misconception has also been debunked. We once believed that skiing below a brutally cold -40 degrees Celsius was impossible. Why? Because it was thought to be too cold for that crucial lubricating liquid film to form. Professor Musa and his team revealed that dipole interactions persist even at extremely low temperatures, all the way down to near absolute zero. This means a liquid film still forms at the interface between ice and ski, even in conditions we once thought defied the laws of slipperiness. The catch? At these extreme temperatures, this liquid film is incredibly viscous, almost like honey. You wouldn't recognize it as water, and skiing on it would be practically impossible. But the film does exist. For someone nursing an injury after a winter fall, the exact scientific explanation might not matter much. But for the world of physics, this distinction is crucial. It opens up entirely new avenues of research and understanding. The implications of this discovery are still unfolding. From designing better, less slippery materials for shoes and tires to understanding ice formations in extreme environments, this research from the Saarland team is making waves in the scientific community. It reminds us that even in the most familiar phenomena, there are still profound secrets waiting to be uncovered. The next time you're out in the winter chill, remember the secret life of ice, a dance of dipoles, not just pressure, that makes our winter world so wonderfully